Okay, so we spent the first half of this chapter talking about ionic compounds. And what's happening in ionic compounds are electrons it's an electrostatic attraction. Positive and negative are attracting to each other to form that ionic bond. In a covalent molecule, which is what we're switching gears to now, we are sharing electrons. Sharing electrons. So remember we said that ionic was two or more nonmetals, and the nonmetals were over here on this side of the periodic table to the right of that metalloid staircase. So covalent molecules are between two or more nonmetals and we'll only be naming two. So we'll only ever be looking at covalent molecules with two nonmetals. There are more complicated covalent molecules that have a lot of nonmetals in them. You'll talk about stuff like that in organic chemistry and biochemistry, but we'll only ever have two. It says two or more, but we will only ever be doing two nonmetals. So there's no ions, so there's no charge to balance. So we can have multiple combinations between the same elements. Granted, this is a covalent molecule, so those elements have to be nonmetals. So let's just look at an example. Let's look at carbon and oxygen. So carbon and oxygen, you can have CO, which is called carbon monoxide, or you can have CO2, which is carbon dioxide. So because we can have multiple combinations between the same elements, we use prefixes to tell us how many of each element we have in the molecule. So you're responsible for the list of prefixes. It's in table 4.4 in your textbook, naming prefixes for molecular compounds. So it goes 1 through 10. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So it's the same prefixes as geometry. So you'll see here the order, remember the order with ionic compounds was it was always the positively charged ion first and then the negatively charged ion. We're not dealing with ions, but it's always will be written in the way that it's named. So it's carbon monoxide. So carbon, you do not use a prefix if there's only one of the first element. For example, CO is carbon monoxide. Mono means one. It is not monocarbon monoxide. This is wrong. Because if there's one, it's assumed that there's just one. So you would say carbon monoxide. And you'll notice whenever the prefix ends in a vowel and then the element starts with that same vowel, you get rid of one of them. So for example, it's monoxide instead of monooxide. I am not going to be worried about spelling or specifics like that. SmartWorks may give you a hard time if you misspell something, or if you were to put two O's in there in monoxide. If you have problems like that, let me know, but this is the correct way to do it. SmartWorks is only set to accept one word. I would be much more lenient on an exam, for example. Okay, so there's multiple different formulas that we can have. Let's just do a few. I'm gonna write some formulas and we'll write the name. Okay, so NO3, this is not to be confused with NO3 minus. NO3 minus is the nitrate ion. NO3 is the covalent molecule, nitrogen trioxide. Nitrogen, again, you don't need to say mononitrogen. You just say nitrogen. Tri means that there's three, and oxide. Another thing is that the second element gets the "ide" suffix. So this is nitrogen trioxide. It's not nitrogen trioxygen. It's nitrogen trioxide. So now let's look at this one. N2O3. So N2 means dinitrogen. 3 oxygens, trioxide. Di is 2, tri is 3. Dinitrogen trioxide. Let's look at one more. P5 is pentaphosphorus. O2 dioxide. 2 di 5 penta, and then the second element gets the "ide" suffix. So a lot less rules and a lot less exceptions to worry about when we're naming covalent molecules. What the most important thing is when you look at a formula, the first thing you should do is identify this as ionic or covalent, because the rules for naming ionic and covalent molecules are totally different. So if you identify it incorrectly, you also will name it incorrectly. So make sure that you are able to identify, differentiate ionic from covalent, and you understand the rules for naming both types.